two coding models both running on this laptop, both handed a bug that actually shipped in this repository. Both fixed it. The smaller one took 13.8 seconds. Then I worked out what running that locally had saved me, and the answer was 1 cent. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. Let me be specific about the bug, because most demos of this kind use a made-up function and a made-up problem. This project has a command called resume2. It picks up a render that died partway and finishes it. It passed a keyword argument named resolution into a function that never accepted one. So it raised a type error immediately, every single time. A recovery path that could not recover. That is a real defect. It was in the repository and it was fixed in a real commit. Which means there is a test guarding it, written at the time of the fix, and that test is what decides the outcome here. Not me reading the output and deciding it looks about right. Not another model scoring it. Here is the whole method, including what it deliberately does not claim. The harness puts the defect back, runs the test to prove it now fails, hands the model the failure and the surrounding function, applies whatever comes back, and runs the test again. Pass or fail comes from Pytest. And the important limitation is in the second half of that file. The prompt hands the model the failing test, the function, and the signature of the thing being called wrongly. About 1,400 tokens, pre-digested. A real coding agent starts from the tests are failing and has to find all of that itself before it can write anything. So this is not a local model against a coding agent. This is a local model on a scoped patch where somebody already did the finding. That is a narrower claim, and it is the one the evidence supports. Now, the results. Both models passed. Qwen 2.5 coder 14B took 13.8 seconds end to end, including 6 seconds to load itself into memory. Qwen 2.5 coder 32B took 25.7, so about 1.9 times as long. And it returned the same fix. Not a similar fix. The same one, minus a trailing comma. The 19GB model produced nothing that the 9GB model had not already produced on this task, more slowly. That is worth sitting with if you have been assuming bigger is the safe default. On a well-specified patch with the context handed to you, the small coding model is not a compromise. It was better because it was done in half the time. So now the money question, since avoiding the API bill is the reason most people give for running models locally. The prompt was a 3062 tokens. The answer was 119. Priced at OBA's 5 list rates, $5 per million in and $25 per million out, that comes to $0.98. Less than 1 cent. I want to be careful here because that number cuts both ways. It is the cost of these tokens, not the cost of the whole job. And a real agent doing the finding as well would spend a good deal more. But it is not going to spend dollars either. It is going to spend cents. So, if you are running models locally to save money on tasks like this, the honest arithmetic is that you would need to do this several thousand times to pay for an afternoon of your own time setting it up. And you would never get back the disk space. The good reasons to run this locally are different ones, and they are real. Your code never leaves the machine. It works on a plane. Nobody rate limits you, nobody deprecates the model out from under you, and the thing you benchmarked in August still behaves identically in December. Those are the reasons. Cost is not. There is one more thing in this run, and I nearly did not tell you about it. The first time I ran this benchmark, it reported that both models failed. I had the table, it was clean, and it made a much better headline than the one I ended up with. Both models were right. My grader was wrong. They returned the corrected call starting at column 0 rather than indented into the function. That is still valid Python, and the file ran fine. But the test reads the function's own source text and cuts the call at a closing bracket indented 4 spaces. With the bracket at column 0, that marker was not there, so the cut ran past the end of the call and swallowed the next few lines of the file. Look at what it then complained about. 2 keyword arguments belonging to a completely different call. A function name that is not a keyword argument at all. And the one name missing from that list is resolution, the actual bug, which both models had correctly removed. The fix was in my applier, re-indent the model's answer to match the code it replaces, which is exactly what you would do by hand. Both models passed immediately. I am keeping that in because of the direction it failed in. I sat down expecting a local model to struggle against a frontier one, and my first result agreed with me. If I had not read the assertion text, I would have published a wrong and entirely plausible conclusion. A benchmark that grades a correct answer as a failure does not announce itself. It just quietly hands you the result you already expected. You can do this on your own repository, and your own bug is better than mine. Find a commit that fixed something real and had a test. Revert the source change and keep the test. The test you already wrote is the grader. The one setting that matters is the context window. Left at its default, the 32 billion model reserves far more memory, stops fitting on the GPU, and becomes unusably slow, which is its own episode, and the previous one. Everything is in the repository below. The harness, the exact prompt, both replies verbatim, and the raw JSON, including the run that was wrong. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.